Next, we talk about software health issue known as the bad code smells. Now, originally, bad code smells were introduced in the context of refactoring in the book by Martin Fowler titled Refactoring: Improving the Design of Existing Code. And the idea of the bad code smells comes from Grandma Brooks, who, according to the book, gave an advice on when it's time to change a diaper for a baby. And the advice was, if it stinks, change it. And this same metaphor with the bad code smells is then applied to when to refactor code if it stinks. So we should think about these code smells as a guideline of lack of following the good universally accepted design principles for software. And for decades or ages, these have been high cohesion, which means that the responsibilities of a software module should strongly be related and focused. So the module should be cohesive so that it's very tightly connected within itself. And when we talk about the module, in different languages, it would have different formats. In Java, it would be classes. In C, I guess it would be modules. And in Python, it would be classes or modules as well. So they should be tightly connected to each other within the module. So each module should be tightly connected, but between the modules, we should have a low coupling. So the modules should minimally interact with each other. So those inter-module, inter-class connection should be minimized. And that is the second principle known as the low coupling. And finally, we have the principle of information hiding. So every software module should capture and hide important design decisions from other modules. And what are these important design decisions? Are something that are difficult decisions or the ones that are likely to change. So you want to hide the stuff that you can then later change within the module, but you keep the interface clean so the other modules do not need to know anything about the internals of the other modules. And so code smells are lack of following these design principles. There's a bunch of others as well, but let's have a look at these code smells next. We will go over bad code smells with the taxonomy, with different classes. And as a first element, we have bloaters. So basically, this is a problem when something is too large. We might have a too long method or too long subprogram, too long routine, too long function, whatever those are called, depending on the language. Other stuff that can be too large is we can have large classes that monopolize the behavior. We already saw this problem with the anti-patterns. The large class was also identified as a problem in the anti-patterns book. And finally, we can have long parameter lists that are also considered as a code smell. So if you pass like 7, 8, 10 parameters, then that is too much. Probably you should minimize to 3 or maybe max 5 in object-oriented languages. Likely these smells grow little at the time. I mean, I hope no one designs long methods. This could also be due to prototyping, where you just try to get something to work and you don't care about the design. And then you think you refactor later, but then you never do for some reason. Next, we have the object orientation abusers. And this is when the object-oriented concepts are not fully understood or utilized. For example, we might have a C programmer coming from the world of procedural programming. And here we have switch statements and alternative classes with different interfaces. As an example of the switch statement, we can see that this would be a typical C type of program where we have a class engine. Well, we wouldn't have classes in C, but we would have this would be a module, and we would have a function inside the engine module, and we would have function cylinder count, and we would have a switch based on the type it does, whether this is family car, then it returns the base cylinder count. If it's the executive car, then it returns the base cylinder count twice 2. And if it's a race car, it returns number of cylinders is always 8 in this design. But this is a procedural design, and in an object-oriented world, you most likely want to subclass this engine. So you would have engine, and then you would have a family car engine, executive car engine, and race car engine. And you would especially want to subclass this when there are other stuff that also varies between the different type of engines. So if it's only the cylinder count, it's probably overdue to do subclasses. But if you have a bunch of other stuff that also changes between the different engine types, then you definitely want to do implement the cylinder class for each, and then you do not get rid of this switch statement. Next we have change preventers, and these are the smells that make changing the system unnecessarily difficult. So of course all smells make changing difficult, but this is sort of a special case of it. For example, shotgun surgery, and this is a case where when you have to do one change in the system, but you have to say change several files or several classes. So for example, if you change your system that currently operates with Oracle database, you change it to working with something else like SQL Server database or MySQL. And now if you need to make changes due to this database change to several classes, then you are suffering from this problem. So the idea here is that all the database changes should be encapsulated within a one class. So no one else in the system knows what database we are using, but there's this one class that encapsulates the database. And then if it works like that, then you're okay. But if you have changed several files, then you are suffering from this change preventer shotgun surgery smell. And this violates the principle that one external change should only affect one class or one module, depending on the language you are using. Next we have the dispensables, and these smells are a problem as all code needs effort to understand and maintain. And if some code is not used or is redundant, it needs to be removed. So we have dead code that is not executed anywhere. We have speculative generality, and this is when you have considered all the future changes that might happen. So you have built too much generality in the system. You have, taken into account everything that might change in the future and built unnecessary complexity to the system. So you have kind of been greedy in the sort of anti-pattern sense. You have done too much speculative design when you don't know what the future will be like. And this is also bad because it's like extra code that is currently not needed, extra abstraction, stuff like that. And finally, we have duplicate code, or it can be not just duplicated, but multiplied several times in the system. And this is actually, according to Fowler, number one in the stink parade. So they think this is the worst. And this has been also recognized by many others. So Cunningham say once and only once. Hunt and Thomas in the programmer, they say do not repeat yourself. And in Finnish we could say you should only program something that has not been programmed yet. And we can have syntactic duplication, which is fragments of code that are identical or near identical. And tools can be a great help in here. They can easily identify syntactic duplication where you just, take direct copy paste with minimal edits. But then we have semantic duplication, which is basically fragments of code that have identical intent but differ at the code level. And looking at the high enough level, we could think that different sorting algorithms would be duplicate code. So if you have implemented quicksort, you have implemented bubble sort and all that kind of stuff. So you have a function that sorts something, but it cannot be identified as syntactically duplicate because it's using a different algorithm. And if there is really no reason to have multiple algorithms in the system, then something should go. Like if you have no reason to have a bubble sort algorithm in your program, then then why are you using it? So just use the quicksort because it's much better. Tools can do very little about this thing. And when the systems grow very large, this actually becomes a problem because no one can keep track of the semantic duplication. And people are wondering, has this type of functionality already been implemented in somewhere else? Or do they need to implement it, do the new program they are just making? So it can be very difficult to find the existing functionality in a large system. Then we have couplers. Low coupling between objects and classes is one of the desirable goals for object-oriented programming. We might have feature envy, where one class is sort of envying other, using lots of its function, using lots of its different methods. So then you might consider, if there is a method inside another class that is heavily using the other class, then should this method be relocated to this class that it's heavily utilizing? So this is the feature envy is sort of a hint that the method is in a wrong place. It should be moved to another class. We might have very long message chains. So A, and then you would ask get B, get C, get D, and then you would just do the operation. So this sort of coupling chains, this can be also, too much. And you can try to minimize the coupling too much by having a sort of middleman that don't do very much. They simply relay messages as you want to couple everything to the middleman, and then you want to couple it out to sort of minimize the number of couplings. But if the middleman doesn't really serve any function, then that also might be pointless. So trying to go too low coupling might also be problematic and considered as a code smell. Originally, the code smells were introduced in Java language, and they have also appeared in Smalltalk. Python language, for example, has its sort of own code smells. I mean, the general principles apply, but then there are special cases that only apply to Python and for other languages as well. So the general ones work for Python, but then you also have others. And I guess C and Rust and whatever other languages also have their other like special smells. So if you are getting paid as a Python programmer mainly, you should definitely study the general code smells, but you should also look into the Python specific code smells. I mean, it's basically looking into these code smells, understanding these things is part of the, let's say, engineering education that you sort of need to take care of yourself while doing the job.